So this is number 12. We have cosine A equals 250 or equals cosine 251. So with this one, this is a definite non-calculator type problem because what we can do is start at 251 degrees. Do an A. Which quadrant would 251 degrees be in? The third quadrant. So if you go around the circle here, 0, 90, 180, 270, so it's right in this area right here. So I'll go ahead and draw that. That is 251 degrees. Okay? If that's 251 degrees, what is our reference angle?
71.
Our reference angle is 71?
No.
Yes, I agree with that. Because you do the 180 plus 71 gives the 251. So there's our reference triangle right there. Okay, we're talking about cosine. So cosine is adjacent over hypotenuse from the 71 here. So our adjacent side right here, our hypotenuse is right here. So with that, are either of those negative?
Yes.
Yes.
If you were to plug cosine 251 into your calculator, you would get 71 then?
No.
What would you get?
You get like negative 0.32 or something like that.
So you don't want to plug it into a calculator.
Okay, so I'm just looking at right there, the adjacent side. Kevin, what'd you say? The hypotenuse is never negative.
It's negative.
So the adjacent is negative. So what other quadrant am I going to have the adjacent side be negative? Second quadrant, right? So if I go to the second quadrant here, like so.
Don't shut it.
Okay. So that second quadrant is also going to be 71 degrees. So if that's the triangle we're looking at, what would that angle there be? It'd be 180 minus the 71, which would you get? 109? There's your answer.
Oh, okay.
Questions there? Okay, now B here is kind of a bit tricky. I was sitting there going, okay, wait, this time it's a little bit different because on this problem, we're not talking about equivalent sines or cosines or any kind of trig function. All these have trig functions. This one doesn't. So it's just saying, wait, where's cosine A equal to 1.5? What's your first reaction to do? Inverse cosine. So inverse cosine of 1.5. And what happens? We get error. What is the problem now? So now usually what I'm doing is I'm kind of freaking out going, okay, I might have done something wrong or something wrong with this problem. So I check my mode. Okay, I'm not in radian mode. I'm in degree mode. I type everything in right. It gives me the error. So now my next step is, well, maybe it's really an error. And so I have to start thinking about cosine. What's cosine again? Like when it comes down to trig functions. Oh, actually, I like this. I like that idea too. I didn't think about that. So you said cosine, when I have our point here, our x value is always cosine of theta. We're using A for this, right? Okay. And what it's saying is that in a unit circle, where that's 1, when is my x coordinate going to equal 1.5? Never. I didn't even think about it that way, but that's true. So that would be a no solution. I like that idea. I didn't think about it that way. Here's the way I thought about it. And I'm more comfortable with dealing with the trig functions in geometry versus unit circle. But what's cosine in terms of trig functions? Adjacent over hypotenuse. So since cosine is equal to adjacent over hypotenuse, if I draw a right triangle, and here's my adjacent side, and here's my hypotenuse, I need to what I need to get is when I divide my adjacent divided by my hypotenuse, get a 1.5. Can I ever do that? We already figured out no, but the question is why not? Because h is always the longest side. So if I do a divided by h, it should always be less than 1 because the adjacent side is always shorter than the hypotenuse. That makes sense? So that's why on your unit circle here it can only be 1. That's the biggest that cosine could ever be. Is when the adjacent side and the hypotenuse are actually equal because the triangle is so skinny and thin. But it can never be bigger, and that's why. Okay, now we're going to look at C here. We have sine of A equals sine 220 degrees. So once again, we're going to start. We want to start at the 220 degrees. We need to begin at our positive x-axis and go counterclockwise 220 degrees. So that would be 90, 180, and then 220 would be somewhere in here. Okay. Now since we went from here to here, that's 180 to 220, this reference angle would be 40. 180 plus 40 is 220. We could draw a reference triangle. And again, this would be 220 degrees, with this being 40 degrees right here. So once we have that, now we're talking about the sine. Now sine is opposite over hypotenuse. So from the 40, our opposite side is here. Our hypotenuse is 1, or here, since we're in the unit circle. Now, because this opposite side would have to be negative because it's going downward, so this opposite sign is negative, which means that sine 220 is negative. So now we just got to find the other reference triangle in one of the other 3 quadrants that would give us a negative sine. Well, if we drew a triangle here by doing this opposite side that would be right here, be reflected over the x-axis, that'd be a positive. Same thing over here. So our reference triangle is going to be right there. It's also 40 degrees, with our opposite side being negative. So now, if we want to figure out that angle, we just start here, work around to there. That end up being 360 minus 40. So 360 minus 40 is 320 degrees. And that is between our 0 and 360, and it's our only other solution. All right, last problem we're looking at is D. We have cosine A equals cosine negative 110. Again, we're going cosine to cosine and negative 110 degrees. Well, that means we're still going to start at our positive x-axis, but now we're going to go clockwise 110 degrees, so that'd be 90, and we need to go another 20 degrees here to hit 110. So something like that maybe. That'd be 20 degrees there. But we have to be careful because it's a little deceiving. Sometimes when we do this, we want to draw this reference triangle, which is not the right one to do. So let's not do that. We always draw a reference triangle to the x-axis, which means that this would be negative 110, and our reference angle right here would be 70. So now, going back in the counterclockwise direction, the way we usually go, I'll use orange for that, we need to figure out what this angle here is. And that angle there would be 180 plus 70, which would be 250 degrees. So that's one of them. It's interesting because this one has two, the last one only had one of the solution. And the reason is because on this solution, there are two angles that had the idea that sine of 220 equals whatever we had for sine of A here. Well, 220 is already between 0 and 360. And there are usually two angles there two reference triangles in our unit circle that'll work. Well, 220 was already one of them. This one doesn't work because it's not between 0 and 360. So we're still going to get, we're actually going to get two answers for this, and one of them is 250, and 250 is equal to the 110, or negative 110. Now we have to use the idea of cosine. Our cosine here, from the 70, the adjacent side is negative, and the hypotenuse is positive always. So now we have to figure out which other reference triangle we're going to use here. Well, we still want an adjacent side that's negative, so it's either here, there in quadrant 1, quadrant 4, and hopefully you see that quadrant 1 and 4 would give us an adjacent side that would be in the positive direction, so it's got to be this one in quadrant 2. So go ahead and draw that. That's 70 there. So what that means now is that this angle right here would be our 180, which is all the way to the x-axis, and then minus 70, so that would be 110 degrees.